right here in this video, we'll be finding the domains of these four functions right here, starting from the first one, alright? Very nice. So we go ahead to evaluate this function and find the domain, that is to say, find the range of values for which x belongs to. And here, we have square root of x squared minus 2, like that. Well, the function inside the square root, that is x squared minus 2, is called the radicand. Very good. And the radicand of a square root should be greater than or equal to 0 for the whole function to be defined. You know, if you have the square root of a negative number is a number less than 0. So if you have a square of a negative number, the result will not exist on the set of real numbers. Okay, so for that not to happen, we need to make the radicand to be greater than or equal to 0, because square root of 0 is 0 and square of a number greater than 0 exists in the set of real numbers, whether irrational or rational. But provided it exists in the set of real numbers, we are done, or we are okay. Alright? Very nice. So like here now, we need our radicand to be greater than or equal to 0, so that's the first step. We say that x squared minus 2 should be greater than or equal to 0, like that. Okay, very nice. Now, on the left hand side, I would like to let you know that we can go ahead and factor this. Okay? By factoring this, I mean x squared minus 2, we can make them difference of two squares. Okay? 2 right here, let me write it at this point. 2 right here is the something as saying square root of 2 and the square of that. Very nice, where the square and the square root can cancel out. Let me write this square to be big enough. Okay, so I can rewrite this as the difference of two squares as x squared minus square root of 2 squared, like that, alright? And from difference of two squares, what do I mean? We mean x minus square root of 2 times x plus square root of 2. And this is the same thing as this. So we get on with it. I'll just go ahead and substitute that, and we will have x minus square root of 2 times x plus square root of 2, right? Very nice. And we say it is greater than or equal to 0. Okay, we'll go ahead and analyze this. Now, for the product of two numbers to be 0, then it shows that one of them is 0 or the both of them are 0. Very nice. For the product of two numbers to be greater than or equal to 0, it follows that one of the numbers or the two of them should be greater than or equal to 0, or the two numbers should be less than or equal to 0. Okay, so from here I would have it that x minus square root of 2, x minus square root of 2 should be greater than or equal to 0, and x plus square root of 2 should be greater than or equal to 0 for this to be possible. For example, you have positive 2 times positive 3, you have a positive result, right? But if you're having negative 2 times positive number, negative 2 times positive 3, you're going to have a negative result because the two of them are not positive and the two of them are not negative. So this is for the positive possibility, and if you have for the negative possibility, it follows that x minus square root of 2, this is or, okay, x minus square root of 2 should be less than or equal to 0, and x plus square root of 2 should be less than or equal to 0. Let's put this place well. Okay, like this. Very nice. So for the first part, we had that this and this should be true. So if the first part is going to be true, x minus square root of 2 should be greater than or equal to 0. It follows that x should be greater than or equal to root 2. And again, for the second part, for x plus square root of 2 to be greater than or equal to 0, it shows that x, just move this to this part, what I was doing, I will move this to the right hand, the inequality, and the negative will change to positive. So here it will just change to negative 2. So x should be greater than or equal to negative square root of, I want to enter my number 4. It is very, very big. Can't you see it? So x should be greater than or equal to negative square root of 2, like that. Okay. Now for the second part, it shows that x should be less than or equal to 2, and again x should be less than the square root of 2. square root of 2, and x should be less than or equal to negative square root of 2, like that. Okay, remember this is a very nice analysis. I didn't just want to jump right to the answer, right? It is good to take it this way so that you just get it. Here we have 4 possibilities that x should be this, should be greater than, less than, and less than. Now we are going to test for each of these values, alright? If x is said to be greater than or equal to square root of 2, we can put that on the diagram. For the first part, we have x should be greater than or equal to square root of 2. If square root of 2 is here, so that is going to be square root of 2. It lies between 1 and 2, alright? 1 and 2. That's 1.4 something. So if we have it to be here, then it follows that x should be greater than or equal to square root of 2. This is for x should be greater than or equal to square root of 2. And again, we have another one there. X should be greater than or equal to negative square root of 2. So we have x square root of 2, and that will be square root of 2. Then you have something to the right side, then you have again, you have square root of 2, you have should be somewhere here. And again, for the last part, we have x should be less than or equal to negative square root of 2. So we can just have this negative square root of 2 be less than or equal to that. Okay. And here, look at this. If x is greater than or equal to square root of 2, then, like I told you guys, square root of 2 lies between 1 and 2. So, if x is greater than or equal to square root of 2, that means square root of 2 will work, or a number greater than square root of 2. Alright, so let's take a number greater than square root of 2, which is just 2. So, plug in 2 right here, we're going to have 2 squared. And 2 squared is going to give us 4. And 4 minus 2 is 2. So the radicand is greater than or equal to 0. It is greater than 0 strictly. Therefore, this man right here satisfies what we want. This man right here satisfies. Okay, we go for the negative part. X should be greater than or equal to negative square root of 2. We go again to analyze that, alright? We pick a number that is greater than or equal to negative square root of 2. In fact, let's pick a number greater than negative square root of 2. Now, negative square root of 2 lies between negative 1 and negative 2. On the negative line, we have 0, we have negative 1, we have negative 2. Square root of 2 lies between 1 and 2. This is 1. It lies between 1 and 2. So the negative of it will lie between negative 1 and negative 2, right? So x should be greater than or equal to negative square root of 2. That means from here forward, like I showed you guys here. So you can choose negative 1 for that. So if you pick negative 1 and plug it in right here, we're going to have negative 1 squared, positive 1, and 1 minus 2 is negative 1. So square root of a negative number, which is negative 1, doesn't exist on the set of real numbers. So this doesn't satisfy what we want. So we don't take that, alright? Again, we go for this. X should be less than or equal to square root of 2. Well, square root of 2 lies here on the positive part, that's on the right side of 0. Now, x should be less than square root of 2, so all numbers less than or equal to square root of 2, we can put 1, alright? Because square root of 2, like I said, lies between 1 and 2. So less than, we go to move to the left, we can choose 1 for that, we can even choose 0, we can even choose negative 1. So I choose 1 for that. I plug 1 in right here, we have 1 squared is just 1. And 1 minus 2 is negative 1. Again, square root of negative 1 doesn't exist on a set of real numbers. So this right here doesn't satisfy what we want. So what do? We do away with it. So we've chosen this one, we took away these ones, we don't want them. Again, to the last, right here, we have that x should be less than negative square root of 2. So since square root of 2 lies between 1 and 2, then the negative of that lies between negative 1 and negative 2. X should be less than or equal to 8. So we can choose negative 2. So negative 2 right here, negative 2 all square. Negative 2 square, just negative 2 all square like this. Not this one, right? Not negative 2 square. No, it's different. Negative 2, all of them square is not the same thing as this. So it's this one we choose right here because we just say x should be negative 2. So in place of x, you put negative 2. Okay, you evaluate it, raised to power 2, you're going to have 4, positive 4. And 4 minus 2 is going to be 2. And 2 is greater than 0, so the square root of that will exist. So this right here satisfies what you want as well. So the two intervals that satisfies is x is greater than square root of 2 and x is less than or equal to negative square root of 2. So what do we say? Well, let me write them out. X, let me use my black ink. That x should be greater than or equal to square root of 2, or x should be less than or equal to negative square root of 2. So from here, we have it that x should be greater than or equal to square root of 2. That simply means x should lie in an interval starting from square root of 2 to the right. Alright? Should be greater than or equal to square root of 2, square root of 2 to the right. That is, it increases without bounds. Okay, that is why I'm putting infinity right here. Or x should be less than or equal to negative square root of 2. That is to say, x should belong to the open and the closed interval. Should be less than. That means I'm going to start from the left to the right, alright? So I'm going to have negative infinity right here and negative square root of 2. Like this. This is how to represent this one, and this is how to represent this one. So this is the interval for which this function right here will be satisfied. So if you pick any element or any member of here or here, it's going to satisfy that. Now, that is to say that x should not be between, that is to say the domain is that x should not belong to the open interval between negative square root of 2 and square root of 2. So the domain is that x should not be here. So it's either you say the domain should be what we want, or the domain should not be what we don't want, right? So with this, you can go ahead and evaluate the domain of this number 1 right here. For the number 2, we'll end this video now, and for the number 2, you move to the next video. Look at the screen, you see the number 2, I cleaned it up right here, so I'm going to write it out and I'm going to solve it again. Okay, I hope this was pretty nice. Remember, you still have 3 and 4. Okay, thanks for watching. Please subscribe to this channel.